Hey, hello, good, I don't know, like for me, it's like good evening, a very late evening, okay? But for people, today I want to talk about this 1.20, this topic 1.20, and it's going to be a part of linear equation system, right? Linear equation system. Um, I want to talk about this one first, right? Do you still remember this one, like A? It's the coefficient matrix, right? Coefficient matrix. And if you have a good sense of like observation, you will see that it must be a square matrix, right? If you have a good sense, okay. Let's go back a little bit. Like I'm gonna take you back. I'm gonna take you back, right? Let's see. If we go back to yeah, like this one, right? We go back to this example. You see this one, right? Matrix A is a square matrix. See, coefficient matrix must be a square matrix. Okay. Next one is a little bit bigger, but somehow like matrix A is still a square matrix, like 3 by 3. Do you know why we have it as a square matrix? Yeah, I think you know, right? And I'm gonna say what you know out. Okay, so what you know and what I know, it's the same, right? It's a square matrix because we have 1, 2, and 3. We have three equations, and we also have one, two, three unknowns. So in the case that we have the number of unknowns equal to the number of equations like this, we will have matrix A, or the coefficient matrix, as the square matrix. Okay, so no problem, right? If we have square matrix, then we can have the solution by using we can find a solution by using the inverse, or we can find a solution by using the Cramer's, right? The Cramer's rule, like that. But if situation doesn't come out like what we know, right? So what we know is just here, right? It says like when A is a non-singular matrix, right? Non-singular matrix means determinant is not zero. Okay, determinant is not zero. Then there will be a unique set of solutions. Yeah, you will get X, you will get Y, you will get Z's. Unique set means you have one possible set of solutions. But in this case, right, when A is a singular matrix, right? The single, not inverse. I'm sorry. I should write like determinant. Okay, determinant. When the determinant is not zero for the non-singular matrix, right, and then just determinant is zero for the singular matrix, like this. Yeah. So when we have a situation, we cannot find the inverse. So what are we going to do, right? So let's say like let's say like some equations in the system are inconsistent, where the coefficients are equal, but the constant on the right are not equal. The system doesn't have a solution. So what does it mean? Right? What does it mean? So I'm gonna show you, like, I'm gonna show you what does it mean. Right? Equations are inconsistent. Coefficients are equal, but the constants are not equal. Yeah, I will show you. I'll show you, right? Just read for you, and it doesn't sound like understanding at all, right? So case number two, right, is the number of equations is less than the number of variables. Number of equations is less than the numbers of variables. Then we will have many possible sets of solutions. Okay, something like, yeah, I'll show you in one of my examples. Okay, so you have to be careful about case one and case two. Where we cannot solve it by like the theory or the concept that we know. Okay, so let's look at this one, right? If you want to find a solution of this system, right, you have this equation 1, equation 2, and equation 3. 1, 2, and 3. You have three unknowns, you have three equations, but if you right, this one, like number 2 and number 3, right? We have good sense of observation. This one, x plus 2y plus c plus z is equal to 1, right? And if you look carefully, hey, this is x, right? But that's 2x, 2 times. It's 2 times, like 2y of 4. That's 2 times again. Z, that's 2z. It's 2 times again, right? So x, y, z, if you multiply by 2, you get this one, you get this one, but you get, and you also get this one. But if you look at here, number one, and if you multiply by 2, you don't get 5. They're not equal. So what does it mean? What does it mean? Right? What does it mean, right? You're gonna have to do something with it, right? And you will end up like this. You will end up like this. 0 is equal to 3, which is like false. And then the system doesn't have the solution. So this kind of situation, I'm gonna take you back to this one, right? Case number 1, right? It's say like some equation in the system are inconsistent. The word inconsistent means it doesn't get along, right? Like that. It doesn't get along. It looks similar, but it's not similar, right? It's say like when the coefficients are equal. Coefficients are equal like this. Like this. You look, right? You have 2, 4, and 2. If you do our equation 2 multiplied by 2, right? You will get 2, 4, and 2, right? So coefficients are equal, but the constant on the right are not equal. What does it mean by constant on the right are not equal? You come and look. You come and look, right? This one the constant. Sorry, like this. This one the constant is 5, right? But this constant is 2, right? All the coefficients are equal. But if you look at the constants on the right, 5 and 2, they're not equal. So if you do something like this, 3 minus 4, right? 3 minus 4, because you want to get rid of the x, the y, and the z that you don't want, and you end up having like 0 is equal to 3, which is impossible, right? Then we can have a conclusion that the system doesn't have a solution. Okay, so that is case number 1, right? That is case number 1. Okay, and if you look at this one, right, I say like A is a singular matrix. A is a singular matrix, which means like the determinant is 0. Uh-oh. Uh-oh. So you come down to this one, right? This one talks about the determinant. How about if we find the determinant of this, right? I mean, like if you have a good sense, you will see that actually number 2, if you multiply by 2, right, you will get the same coefficients as number 3, right? I mean, if you have a good sense, but how about if you don't have a good sense? How can you know? How can you know that the system doesn't have a solution? So you just have to check at the determinant, okay? You check at the determinant. So if you want to check it out, so you have to write all the coefficient of them, right? 2, 3, 1. Okay, you write 2, 3, 1. You go back, that is 1, 2, and 1. Yeah, you go back there, 2, 4, and 2. Right? And then you find determinant of them, right? So just copy and paste a little bit. So you're gonna have this 2, 1, 2, and 3, 2, 4, right? And let's find the determinant of it. You cross down, that will be 8. Cross multiplying down, that's 6. Cross multiplying down, that is 4, right? Cross multiplying up, it's 4. Cross multiplying up, it's 8. Cross multiplying up, that is 6. And then you have to see, right? This one you have 8, 6, 4. Up there you also have 8, 6, and 4. So you have all the same like constant. All 3 constants the same. If you find the sum of them, you will have 18, right? If you find the sum of them, you have 18 as well. If you subtract them, like down minus up, you end up having 0, right? When the determinant is 0, what is happening? What is happening? We will have a singular matrix. Singular matrix doesn't have the inverse. Why it is not having an inverse? I will tell you like this. Because when you find inverse, right, the formula is 1 over the determinant of A. And then multiply with the adjoint matrix, right? Adjoint matrix of A. You look at this one, right? If the determinant is 0, like this case, like determinant is 0, so you end up having 1 divided by 0. 1 divided by 0 is undefined. When it is undefined, then you cannot have an inverse. When you cannot have the inverse, you cannot find the answer. Why you cannot find the answer? Because to get the answers, you may get through this one, right? You may have to use like inverse method like this. Okay. So I think you know what I mean, right? You know what I mean now. Okay, so that is case 1. I already explained to you about the case 1 already. Then we want to go to case number 1 or 2. Okay, let's see this one a little bit. Right? Find a solution of this system. 242 something. You just want to look again, eh? Again. Like you want to look at this one. Equation 1, yeah, something like this. Equation 2, hey, you look at this. 1 2 1. Equation 3, 2 4 2. You will see that equation 3 is like 2 times of equation 2 when you look at the coefficients, right? You have your sense now. If you see something like this, you can just tell other people like right away that this one will not have the solution. Why? Because you will end up having something like that. And if you don't know what to say, right, you just find the determinant. Yeah, find the determinant of this system, and determinant will be 0. Determinant will be 0. If you see something like this, you see, right? Coefficient of the second row, and that is the coefficient of the third row. If you multiply like this, you see, exactly like 2 times. Exactly like 2 times. Okay. So be careful about this. Okay, be careful about this. Don't waste your time. Okay. So that's all about case 1, right? Case 1. Case number 2, I'm gonna talk about it. Maybe next one, right? Yeah, I can talk about it like next one. Like I can talk about it in the next topic. Okay. So this one, like in this case, right, we make like a new topic to talk about case 2, where your coefficient metric is not a square matrix. This one occurs if the number of unknowns, right, is not equal to the number of equations. Here you have like 3 unknowns, right? If you go back there, you have equation 1, you have equation 2. See, you have the number of equations less than the number of unknowns. So your your matrix, your coefficient metric is not a square matrix. When it is not a square matrix, you cannot find the determinant, you cannot find the inverse. Right? So what is our like conclusion, right? What is our conclusion? We have to conclude that it will have many possible solutions, right? It will have like many possible solutions. Okay. Next one, right? The other case, right? The other case. Here you have 1, 2, and 3. You have 3 unknowns, but somehow you have 1, 2, 3, 4. You have 4 equations. Again, your coefficient metric is not a square matrix again, right? But this one is a little bit like spatial, right? It's say like the number of equations is, I don't know, not okay. I'm gonna read again. Like, so the example, the number of equations is less than the number of variables. The system has infinitely many solutions. This sentence talks about this example, right? But in case that inconsistent occurs, what's the meaning of inconsistent, right? In case the inconsistent occurs, the system turns to have no solution. So this one means okay, I don't have to explain it here. I'm just gonna take you back. Inconsistent occur when we have some situation like this, right? Some like row number 2 is like 2 times of, I know, row number 2 times 2 is row number 3, like that, like this. This one is called like inconsistent. Okay. So from this example, I'm gonna take you down here. We want to find a solution of this system, right? Okay, let's do it now. We want to find a solution of this system, right? Okay. Can we do it with metrics? No, we cannot do it with metrics. So what do you have to do, right? First step, right? First step, you have to find a way to eliminate one one variable out. So I think the easiest one is this one, like z and c, because they have the same coefficient now. So maybe you want to do something like 1 equation 1 minus equation 2, something like that. Equation 1, yep, minus with equation 2, right? And then you get like x plus y is equal to number 2, and that is your equation number 3, right? So next step, you just have to assume a new variable. You have to assume a new variable, something like this, like let x equal to a new variable, maybe a letter like c, okay, a thing called c, where your c is anything in the set of real number, right? C is at, yeah, it looks like letter G. Okay, so I'm gonna fix it. C is anything in a set of real number like this, right? So you go back to equation number 3 a little bit, right? Your x is now equal to a constant c plus y, and that will be equal to number 2, right? You change side of it a little bit, right? And you will have y equal to 2 minus c, right? And you keep this one. So 2 minus c. You keep this one. Okay, you keep this one. Maybe I put in a box like that. And then you take this one, put it back there in equation 1 or maybe equation 2. But I think I'm going to choose equation 2 because I feel that it's easier. So I'm going to say substitute this one back in equation number 2, right? So I'm going to get my x is now, this x, right? This x is now equal to c cat already. And 2y, right? 2y, I'm going to have like 2, and then my y is now equal to 2 minus c, right? Equals 2 minus c, and then plus letter z, and that is equal to number 1. I'll do the math a bit, like c plus 4 and minus 2 times of c cat plus z, and that is 1. So what is this? I'm gonna have like negative c, and then okay, maybe make it easy, make it easy, make it easy. I would just have this letters z alone. The other side, right? 4, move it there. 1 minus 4 is minus 3. And then c minus 2c is negative c. Move it to the other side. I'm going to have a positive 1. So letter c is like, letter z is c minus 3. Okay. My answer would come out to be like this. So the system has the answer like this: x, y, and z. Like this one is called like this is like the not the other pair, right? But because we have three variables, we're gonna call it like the other triples. The other triples. Okay, so it looks like this: x is now equal to c cat, y is now equal to 2 minus c cat, right? And then z is equal to c cat minus 3. C cat minus 3. Yep, when your C cat is any real number. So this one we say that we have infinite number of solutions. Okay, infinite number of solutions. It depends on C cat. For example, let's say if my C cat is 1, okay, if my C cat is 1, then my solution will come out to be something like 1 like this, and 2 minus 1 is 1, 2 minus 3 is minus 1, something like this. Okay, that is just one let's go back to last term a bit. Like this is just one like subset. Okay, this is like one subset of one solution. Okay, like subset of all possible solutions. We have infinite number of solutions here. Okay, so you get it now, right? So in the case that we have the number of equations less than the number of the variables or the unknowns, then we are going to have infinite number of solutions like this. So let's go to the next one, right? Let's go to the next one. Let's go to the next one. This one we have, oh, just 2 equations, right? But we have 1, 2, 3, and 4. 4 unknowns. A lot, right? A lot of unknowns. So this one, let's see how do we solve it. How do we solve it? Like, so if you just look, first step is the same. We have to eliminate, right? we have to eliminate one equations, not one equation, I'm sorry, like one variable. But if you look, this is like positive t, that is negative t. So I think that you want to do 1 plus 2, right? Because you can eliminate t. So it's gonna come out to be 3x and then 6y, and this one is like 5 times of z, and that will be equal to 3, and you let it be like your equation number 3, right? Sorry, I feel like actually like I have a little bit of sore throat, so I think that today my clip will last for like half an hour. I'm not gonna do it longer than that, because if I do it longer than that, I feel that the short thing will happen. I'm gonna lose my voice for sure. So it's about in about like 10 minutes. I'm gonna stop it. Okay. Okay. So now we have this one, right? 3x. Oh, oh, I feel like very itchy. Sorry, like very itchy now. Then you just have to assume maybe your what you want, like maybe your x, right? Let's x equal to z something. Let's x, okay. Let's your x, okay. Okay, maybe you let your x equal to c cat, right? Let x equal to c cat, where again like c cat is equal. No, c cat is a member of real number. So what do you get? Like you will get something like uh what is that? Okay, so you're gonna get this 3 times of c cat plus like 6y plus 5z, that is equal to 3. Uh-huh. Right. Okay. Next one, right? You have to move it somehow like this. I'm gonna be like 6. I'm gonna do like 6y is equal to 3 minus 5z and minus 3 times of c cat, something like this. 6y is gonna look like that. Hey, no, 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 I don't think that it will come out to be okay, right? Okay, let's fix it a bit. Let's fix it a bit. Okay, I think that it's not a good way, because I feel that we may have a better way to do it. I know, I know. Yeah, I'm sorry. Yeah, this is like a little bit like waste of time. Okay, so we go back a bit. We go back. I'm looking at this one, right? I am like I'm a little bit like callous. Like when I see this T and negative T, like I feel like I want to do it here. But if I do it here, I can just eliminate T out. But if I come back and then I take it a little bit like slower and think carefully, you look at this. X 2x 2 times, 2y 4y 2 times. So if I just multiply equation number 1 by 2, right, I can eliminate like two variables at the same time. You see, right? You see, right? I can eliminate two variables at the same time. So what I'm gonna do is equation 1 times 2. I will get my equation 3, and this one is going to be better. So I'm gonna have like 2x plus 4y plus 2z, and then plus 2 times of t, and that will be equal to 6. All right, and now I'm gonna do 2 minus 3, equation 2. Okay, equation 2 minus equation 3. All right, so now I can eliminate x, I can eliminate y, and this one is must be number 2, not zz, right? Like 4z minus 2c, I'm gonna have like 2z left, right? And then yeah, left, right. Okay, and then negative t minus 2, it's negative 3 t. and it's gonna be equal to -6. So now I have like just two variables. I have two variables now. Then I'm gonna assume letter Z. Okay, maybe letter C. Assume it to be C cat, where Z cat is the member of any real number. And then I'm gonna replace it to be 2z minus 3 times 3t equals to -6. Then my t, right, my t, yeah, my t. If I do it okay, slowly, okay, slowly. So my t, right, I'm gonna have to move this one there, right? -3 times of t is -2 c cat minus 6, and divide everything by -3. So my t is 2/3 of c and plus 2. Okay, so keep it. This one is gonna be mine, maybe equation number 4, right? Equation number 4. Then I will just go back and substitute now. I will just go back and substitute um, up there in equation 1. In equation 1. Okay, equation 1 is easier. Okay, so go back. Let's put it back in equation 1. Jump back in equation 1. So I'm gonna have x, right, plus 2y, and then x plus 2y plus c cat, right? Because now my z is equal to c. My z is equal to c, and then this t is now changed to that plus 2/3 of c cat plus 2, and that will be equal to number 3. So I'm gonna do the math a bit. Yeah, just 2, right? So I'm gonna do the math a bit. I will have like x plus no, maybe I just want to have x alone. Okay, this one is a little bit hard. Like, okay, I want to have x alone. So let's, x is -2y, and that is like 3/3. So that is plus, will be 5/3. I move it to the other side, then I will have it minus 5/3 c cat, and then to move there, I would have plus 1 left. I will have plus 1 left. Okay, next one. I still have like two variables, then I have to assume again. Okay, let my y equal let's say k, y equal to k, where my k can be any real number. K can be any real number. Yeah, k can be any real number. Then I'm gonna have it like this: x equal to -2k, right? -2k minus 5/3 c cat, and then plus 1. Something like this. Next, I'm gonna go to give you the answers. Okay, I don't know how to call this one now. For 3 variables, we called it like auto triple, but I don't know about this one. How do we call it when we have like 4 of them? I don't know. Other quadruple or something. Okay, so it will come out to be like this. X is now equal to this one, right? X is now equal to this one. Right, my x is now equal to this one, -2k minus 5/3 c cat plus 1. Right, my y is now equal to k because I assume it already, and then my z is equal to that one. Right, I assume it already, c cat, and then my t is there in this equation. So it's gonna be like 2/3 of c cat plus 2, like this. So if you want to have the answer of this one, you have to think of any k, any value of k, and any value of c that you like, and you just have to substitute. So at the end, I don't know, but we know that, I don't know what will be the answer, but we know that we have infinite numbers of solutions. Okay, we have infinite number of solutions. Okay. So what is this one? What is this one? It say like the patterns of solutions are vary depend on which variable is assigned to the constant. Okay, assigned to the constant. I think I'm gonna stop it here, right? The next time I'm gonna come back to talk about this topic, okay? Maybe tomorrow, because today I'm gonna stop now. I feel like not okay. I have a sore throat now. So thank you very much. I will see you in the class tomorrow. And if you have any questions, come to ask me. Okay, I'll be there to help you. Bye bye.